Hello, this video is nothing to do with static electricity. That's why the balloons are stuck on the wall. That was a previous video. This video is about how to make the most fantastic, one of the best examples of Michael Faraday's demonstration of magnetic field lines. And you're going to need two things. You're going to need some magnets. These are a couple of bar magnets that I've bought on the internet. They're about 4 inches long or 100 centimeters, and they cost me about £8. And I also bought some iron filings on the internet, but they were a bit coarse. They were a bit like granulated sugar. So I made my own iron filings, and that's what I'm going to show you right now. I'm going to move the camera down so you can see the table. I've got here, surprise surprise, a file and some iron. Now I chose this particular iron because it's the iron that's in an old transformer, and I happen to know that the iron that they use in transformers is soft iron, and that will be the easiest to file, and it also means that when you take a magnet away from soft iron, it demagnetizes it. It's only magnetic when there's a magnet near it. So I've got here a piece of white paper. The bigger piece of paper is just to catch any stray filings, and I'm going to file some nice fine filings which are almost like dust. There we go. Then fold my piece of paper, collect all the filings in a little line like that, and put them into a little glass pot. Now I call this pot my pepper pot. There we go. Because it's a little jam jar, and I've taken the lid and I've punched some little holes in it. I started off with one, and then I ended up putting a lot more in. So that's how I get my filings in there. I'm going to make another video later to follow this one, explaining some of the scientific theory. But I thought with this video I'd just get on and show you how to make a reproduction of Michael Faraday's lines of force. He fixed his force with candle wax, but I'm not going to do that. I'm going to show you this one. This is one I did earlier with candle wax, and if you get a light shining nicely on it, you can see it glistening. Sorry about the shaky hand. But those iron filings have been melted with candle wax and fixed there. But the video I'm going to show you, the filings, we're just going to photograph them. This is a demonstration of a magnetic field. Here I've got a bar magnet with a north and a south pole, and I'm going to lower a piece of paper that's had iron filings carefully sprinkled onto it, and you can start to see the magnetic field pattern emerging. But now what I'm going to do is I'm going to start tapping the paper, and this is what really develops a beautiful picture of the magnetic field. Now I probably need to stop there because that's probably the best I'm going to get, but for the hell of it I'm going to continue and see what happens. You can see that the field lines are much larger than this image. They're going out beyond it. This is a demonstration of the magnetic field lines that you get between two attracting poles. So we've got a north pole here and a south pole there, and both these magnets are stuck to the board with a piece of blue tack, otherwise they would jump together. But I'm now going to lower a piece of paper with iron filings which have been sprinkled onto it. I'm going to very carefully lower this down onto the magnets, and you can start to see the magnetic field pattern of those two magnets which are underneath, and you can see where the poles are. But when I start to tap the piece of paper, you can see field lines developing, and you can see here where the north and the south pole are closest together. You've got, and also where the field lines are closest together is where you've got the strongest force between the two magnets. I'm just going to keep tapping a little bit longer than this, but that's pretty good where it is. That's a moderately good pattern of the attraction, field lines of the attraction between two attracting magnets, a south pole and a north pole, attracting each other. Next one I'm going to do is two poles repelling each other. Here is a demonstration of two north poles, or two like poles, repelling each other. I've got quite a reasonable distance between the two. I'm going to lower a sheet of paper which has got iron filings on it, very carefully sprinkled on. I'm going to lower it down onto the magnets. There we go, and you can see where the poles, these are the two north poles, and now we want to see what pattern the magnetic field will produce between the two repelling poles. So we're going to give this a tap, and you can quite nicely see, it's a little bit diagonal, there's a line between the two repelling magnets where this magnetic field has been distorted by this magnetic field. So instead of getting a nice curve that you normally get, when the two fields meet each other, they're repelling each other, and you get this line between the two repelling magnets. I find that it's better to sprinkle the filings onto the paper away from the magnets and then lower it gently onto the magnets, because if you put your paper on top of the magnets and then sprinkle it, the filings, a lot of filings tend to end stuck to the poles, and I think you get a better result if you sprinkle your filings onto the paper away from the magnets. I wanted to show you a few of the bits and pieces that I've used for filming the magnetic field. I've put my camera on top of here. It can be the tablet, but I'm filming on the tablet, so it can be your smartphone, and the lens is just hanging over the end there. And the advantage of this is that you can put whatever you want to film underneath there, and you can adjust this up and down. It just slides up and down this rod, and because it tips forward, it locks itself in whatever position you want it to be. I've also made this frame. So I've stuck the magnet down with some blue tack to stop it slipping about. What's quite important is that you have something flat, a piece of card. In this case I've got a piece of Perspex, and I've also put some blue tack under the corners of this piece of paper. Now it's very important that the paper is very flat, goes in there, and when it's under the camera it's got to be extremely flat, because when you start tapping, if there's any bumps in the paper, the filings will produce a false impression. So that's the technique I'm using for filming the Faraday's filings. If you like this video, please give me a thumbs up, and if you want to see some more experiments, subscribe, and I might have some more videos. Now excuse me, I'm going to read my script because I can't remember it all. I want to highly recommend a series of videos called Kathy Loves Physics, in which she tells some very accurate stories about the history and the people and the discoveries in science. Kathy has gone to a lot of trouble and uses a lot of original letters and documents to get her information correct, as well as being very interesting. Maybe start with one of her earlier videos called, what's it called? How Electricity Got Its Name from Jewellery. This video could be of interest to even quite young children. It's a good story. And I think and some of her videos are a bit specialised. But give a few of them a try before you give up. I happen to think that they are all excellent. I have some more home experiments involving jumping balls, bending water, ringing bells, Faraday's motor, and rolling drinks cans. I try not to show you the experiments, just show you the experiments, but I have drawn some diagrams and explanations of what science thinks going on. Goodbye for now. Maybe I'll see you again in another video, and good luck if you are going to try these magnetic experiments. I have done previously a video called Sailing Faster 2. That's not 2 somewhere, it's written like that, Sailing Faster number 2, which deals with the forces, analysing the forces that take place when you're sailing. And sailing just happens to be another of my passions. Before I go, I've got to tell you this. I've just discovered on Spotify, and they're also on YouTube, this amazing New Orleans street marching band. And I just happen to like traditional jazz, so I think look these people up, because they are fantastic. So bye again, signing off, Colin McCowan. Bye.